Hello viewers, if you are from the construction industry or if you have done any concreting activities, then you might have seen formation of minor cracks while the concrete is still in fresh state, and that is known as plastic shrinkage cracking of concrete. My name is Surikant Padi, and in this video we will discuss why this type of crack occurs and how does it look like, and most importantly how we can prevent the occurrence of this type of crack. So let's start why this type of crack occurs. Just after placement of concrete, when we compact the concrete, heavier materials tries to move downward while water, being less dense element of the mix, tries to move upward towards the surface. And this upward movement of water creates a very thin layer over top of the concrete surface, which is known as bleeding of concrete. And when this bleed water is subjected to surface evaporation, there is a water loss from top of concrete surface. And because of this water loss, there is a contraction over top of concrete surface, resulting plastic shrinkage crack. Now, you can say the magnitude of plastic shrinkage crack depends on the rate of loss of water over the top of concrete surface. Now, there are three primary factors that affect the rate of water loss. The number one is ambient air temperature, second one is relative humidity, and third one is wind speed. Because all of these three factors, there is a water loss from top of concrete surface. Now you can say if the rate of evaporation of water from top of concrete surface is greater than the rate of bleeding of concrete, then there is a net reduction in volume. Now this net reduction in volume causes the top of concrete surface to shrink, but the top surface of concrete shrink cannot happen because it is restrained by the underlying layer, because underlying layer is not subjected to the same kind of rate of moisture loss. So it is restrained by underlying layer. Also, it is restrained by the reinforcement. It is restrained by the subbase in case of slab on grade concrete. Also, it is restrained by the frictional resistance offered by the formwork surface. And because of all this restraint or resistance, the top of concrete surface cannot shrink. And because of this, tensile stress develop over the top of concrete surface. And as you know, when the concrete is in plastic state, has very little strength, and so it cannot resist the tensile stress, causing development of plastic shrinkage crack. If you take a wet clay and you spread it and you let it dry, then you can see that there is a formation of cracks over the clay surface. The same phenomenon happens also in concrete. So hopefully now you understand why this type of crack occurs in concrete. Now let's look at how does it look like. The maximum width of plastic shrinkage crack can be up to 3 mm, but in general it can vary from 0.5 to 1.5 mm, and the depth of that crack is generally 20 mm to 50 mm, and gradually and rapidly tapering down. What I mean, I'll show you an image so that you can better understand. See this image. The width of this crack, that is 3 mm, and the depth can be 20 to 50 mm, rapidly tapering down. You can see here. And the length of this type of crack can vary from 50 mm to 2 meter, 3 meter. And based on its appearance, it can be two types. One is diagonal cracking and another one is map cracking. In case of diagonal cracking, the approximate angle in which it appears is 45 degree to the direction of casting. What I mean, you see this. Hope you can see it. This is the diagonal plastic shrinkage cracks. These cracks are parallel to each other, and this at an angle of 45 degree to the direction of casting. And the distance between two cracks can vary from 1 meter to 2 meter. Also, this varies from how you do your finishing operation. Now the next one is, can you see it? This is map cracking. This is map cracking. And this map cracking forms randomly when your surface is very large. Suppose you are casting a slab or wrap, then there are chances that you can see this type of map cracking. And again, that depends on how you start your finishing operation. Hopefully now you understand how it doesn't look like. Now let's talk the most important part of this discussion. How can we prevent formation of this type of crack? As I told you earlier, rapid evaporation of surface moisture is the primary cause behind plastic shrinkage crack. And this evaporation happens because of temperature, humidity and wind speed. And most of the time what happens, we give importance to high temperature situations, neglecting the wind speed. Let me give you a statement. Either you increase the wind velocity by 8 km per hour, or you increase temperature by 10 degrees Celsius. Both of these two conditions will have equivalent effect on fresh concrete. Do you understand this? Either you increase wind velocity by 8 km per hour or you increase temperature by 10 degrees Celsius, both of these conditions will have same effect on fresh concrete. So don't neglect the wind velocity criteria, because most of the winter seasons the wind velocity is high. So therefore some wind breaks must be erected if you are doing concreting activities in any windy situation. And curing. Early curing is the key. Now start curing of concrete as early as possible, just after 1 hour of casting of concrete. And curing, when I said curing, I recommend using polythene sheet to cover the casted concrete surface. This is the best way to prevent plastic shrinkage crack. We use polythene sheet within 1 hour. After casting concrete structure, within 1 hour, put a polythene cover over the casted concrete surface. And another one, a technique you can use is using fiber in your concrete mix. I'm talking about polypropylene fiber. And these fibers act as tensile reinforcement, which helps concrete prevent tensile stress, to resist tensile stress caused by the restraint, as I talked about earlier. So you can use polypropylene fibers in the concrete mix, or you can use early curing. You can erect wind breaks. So these are few of the techniques you can employ to prevent plastic shrinkage cracking of concrete. So curing is the most important factors. So hopefully now you understand how to prevent plastic shrinkage cracking of concrete. Thank you.